Welcome to Math Quest. In this session, we will discuss about coordinate geometry, area of a triangle. In this session, we will learn about derivation of area of triangle formula, collinearity of points by using area of triangle formula, and areas of quadrilaterals. B equal to x2, y2, C equal to x3, y3. Now, how can we find area of this triangle by using coordinate geometry concept? Let us observe the diagram. Consider this is the triangle vertices A, B, C here. That means this is x1, y1, this is x2, y2, and this is x3, y3. Whatever the formula derivation, we need to focus on the horizontal distance and vertical distance. So for that reason, draw the perpendiculars from A and B and C to the x-axis. Say the perpendiculars AM, CN and BP. Now, we need to find out the area of this triangle. If you observe the diagram properly, AMPBC is a pentagon. And if you observe AMNC, it is a quadrilateral in which these two are perpendicular to same line, therefore they are parallel. Hence, AMNC is a trapezium. CNPB is also a trapezium, the same manner. So, we can consider here the area of the pentagon is nothing but area of trapezium AMNC plus area of trapezium CNPB. Now, our intention is to find the area of this triangle. If you remove this area of this triangle from the pentagon, you can have AMPB. Again, it is a trapezium. So, area of triangle ABC is nothing but area of trapezium AMNC plus area of trapezium CNPB minus area of trapezium AMPB. So, the entire triangle area can be expressed as algebraic sum of these three trapeziums. Let us identify their measurements. This is the horizontal distance Mn, that is difference between the x coordinates. This is x1, this is x3 as per our diagram. So this will be x3 minus x1. Similarly, this is x2 and this is x3. Therefore, this distance will be x2 minus x3. The vertical distance AM is nothing but its y coordinate y1. The vertical distance CN is nothing but here y3. The vertical distance BP is nothing but y2. Now, once again, if you come back to the trapezium AMNC, the height of the trapezium or the distance between the parallel sides is nothing but Mn. So, the height of the trapezium is nothing but x2 minus x1 and the lengths of the parallel sides are nothing but y1 and y3. Now, let us derive the formula of the area of triangle. So, area of trapezium. We know that area of trapezium formula is half into sum of the distances of parallel sides or lengths of the parallel sides and the perpendicular distance between the parallel sides. Or else we can write in a simple manner, area of trapezium is half h of a plus b, where a and b are lengths of the parallel sides. If you observe the diagram here, this is nothing but area of trapezium AMNC is nothing but half of the parallel sides are AM plus CN into the height is nothing but MN. Similarly, this is half into area of parallel sides are nothing but CN plus BP into height is nothing but NP minus area of trapezium AMPB is nothing but half into AM plus BP into height is nothing but MP. Once again check the diagram. Now, from the diagram, we know that AM value is nothing but Y1, CN value is nothing but Y3, so it is half of Y1 plus Y3 of MN value is nothing but X3 minus X1 plus half of CN value is nothing but Y3 and BP value is nothing but Y2 and NP value is nothing but X2 minus X3 minus half of AM value is Y1 and BP value is Y2 of and the MP distance is nothing but X2 minus X1. If you simplify, area is equal to half of, you can take half common in all the three terms and expand. So multiply with individual terms, y1 into x3. I'll write for the convenience x first and next y. So this is x3 y1 minus x1 y1 again with y3 plus x3 y3 minus x1 y3. Similarly, the second one y3 into x2, so plus x2 into y3 minus x3 y3 plus x2 into y2 minus x3 into y2, and the next last one minus of y1 into x2, so minus x2 y1 minus into y1 into minus x1, so plus x1 y1 minus into y2 into x2 minus x2 y2 minus into plus y2 into minus x1, therefore plus x1 y2. If you observe the terms, all the terms, compare whether any positive and negative terms or equal terms are there to cancel. If you identify here, x1 y1 is there, this x1 y1 minus x1 y1 is there, here it is plus x1 y1 is there, so therefore both will be cancelled. Similarly, Here it is plus x3 y3 is there. Here it is minus x3 y3 will be there. So therefore both will be cancelled. Similarly, here it is x plus x2 y2 is there, and below it is minus x2 y2 is there. So both will be cancelled. So total 6 terms are cancelled. Now the remaining how many are there? 1, 2, 3, 4, 5 and 6 terms are there. So I want to write the terms with respect to same corresponding x coordinates. That is, if you observe the x1, the remaining terms are having x1 here, x1 y3 minus, and here plus x1 y2. So among the two I will write first. So x1 y2 minus x1 y3. Similar fashion, go for x2 terms. Here it is x2 y3 plus x2 y3 is there. Again below it is minus x2 y1 is there. So x2 y3 minus x2 y1. Similarly, here it is x3 y1 is there plus, and here it is minus x3 y2 is there. So plus x3 y1 minus x3 y2. Now if you observe them, arrange them as a pairs. Among these three pairs, if you observe, x1 is common, here it is x2 is common, here it is x3 is common. That is the intention to write them as pairs. So take that term common, that is nothing but half of x1 of y2 minus y3 plus x2 of y3 minus y2 plus x3 of y1 minus y2. So this is the formula for area of triangle when the three vertices x1, y1, x2, y2 and x3, y3 are given. So the area of the triangle whose vertices are x1, y1, x2, y2 and x3, y3 is half of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. Here x1, y1, x2, y2, x3, y3 may be positive or negative. So the resultant value may be negative or positive. But area is always positive. So you can, even though if you got negative answer here, suppose you got the area value, this total value you got minus 7. But you need to write the area is 7 square units. Or else, we can write, instead of checking that, we can use the formula as half of modulus of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. We can use absolute value modulus to represent only the positive. Now, to remember this formula, we can use the shortcut. For example, consider a triangle. In this triangle, the vertices of the triangle considered as y coordinates, say y1, y2 and y3. The opposite sides of these vertices consider corresponding x coordinate. That means this is y1, opposite is x1, this is y2, opposite is x2, this is y3, opposite is x3. Now, area of the triangle is nothing but half of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y3. So you can use in this way cyclic manner. But this is, remember, this is not a formula, it is only for shortcut. Once again, half of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. Let us observe some examples. Find the area of triangle formed by the vertices 1, 2, 2, minus 3 and minus 1, 3. So consider that A is equal to 1, 2, B is equal to 2, minus 3, C equal to minus 1, 3. We know that area of triangle formula is half of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. So let us substitute those values here. Consider this is x1 y1, x2 y2 and x3 y3. Now substitute. In place of x1 here it is 1 of y2 value minus 3 minus of y3 value 3. So minus 3 plus x2 value 2 of y3 value 3 minus y1 value 2. So 2 of 3 minus 2 plus x3 value here minus 1. Therefore plus of minus 1, that is nothing but minus 1 of y1 value 2 and y2 value minus 3. So minus of minus 3 plus 3. So if you simplify minus 3 it is nothing but minus 6. Minus 6 into 1 minus 6. 3 minus 2 is 1. 2 into 1 is nothing but plus 2. 2 plus 3 is 5. Minus 1 into 5 is nothing but minus 5. If you observe here minus 6 plus minus 5, it is minus 11 plus 2. So you are getting half of minus 9. Since area is positive and also we have kept the modulus, so you have to consider only positive value 9 by 2 square units. Let us observe another example. Find the area of triangle formed by points 3, 1, 0, 2 and minus 3, 3. So let A equal to 3, 1, B equal to 0, 2, C equal to minus 3, 3. If you apply the above formula, half of modulus of 3 of 2 minus 3 plus 0 of 3 minus 1 minus 3 of 1 minus 2. Here, whenever any x coordinate is 0, even though you can skip this entire term, no need to write. So, but to explain the general formula, I have written here. Now, 2 minus 1, 3 is nothing but minus 1. Minus 1 into 3 is nothing but minus 3 and this is 0. 1 minus 2 is nothing but minus 1. Minus 1 into minus 3, it is plus 3. So minus 3 plus 3 become as 0. So you got half of 0, that is nothing but 0. So what we have observed, area of the triangle becomes 0 square units. That means triangle is not formed. So we can conclude from this, if the area of triangle is 0, then the 3 points are collinear. So this is the another condition to prove the collinearity of 3 points by using area of the triangle formula. We have discussed already 3 cases. One is by using distance formula, and another one is by using section formula, and the third one is by using area of the triangle formula. But please remember, in any examination point of view, whenever they have given any point is unknown among the 3, not to use distance formula for collinearity. It will be more complicated case. So either you can use section formula or you can use area of the triangle to check the collinearity of 3 points. Now, let us discuss how to find the area of a quadrilateral. For suppose, observe this problem. Find the area of quadrilateral formed by 2, 1, 3, minus 1, minus 1, 3 and 1, 2 in an order. Let us observe the solution. Here, we need to find out the area of quadrilateral. For example, if ABCD is the quadrilateral, you join any diagonal, it is divided into 2 triangles. So area of this quadrilateral is nothing but area of these 2 triangles summation. So consider let A equal to 2, 1, B equal to 3, minus 1, C equal to minus 1, 3 and D equal to 1, 2. So area of quadrilateral ABCD is nothing but area of triangle ABC plus area of triangle ACD. So area of triangle ABC is nothing but half of. Here we have chosen the points A, B and C. So 2 of minus 1 minus 3 plus 3 of 3 minus 1 minus 1 of 1 minus minus 1, that is nothing but 1 plus 1. If you simplify, half of modulus of 2 of minus 1 minus 3, it is nothing but minus 4 plus 3 of 3 minus 1, it is nothing but 2, 3 of 2 minus 1 of 1 plus 1, it is nothing but 2. If you simplify more, half of minus 8 plus 6 and minus 2. So minus 8 minus 2, it is nothing but minus 10 plus 6, it is nothing but half of modulus of minus 4. Since it is absolute value, you will get plus 4. 4 by 2 is nothing but 2. So the area of triangle ABC is 2 square units. Let us observe the area of triangle ACD. In the same manner, half of 2 of 3 minus 2 minus 1 of 2 minus 1 plus 1 of 1 minus 3. If simplify, 2 of 1 minus 2 minus 1 is 1, 1 of 1 plus 1 of minus 2. That is nothing but 2 minus 1 minus 2. Plus 2 minus 2 cancel, you are getting minus 1 under modulus. So half of modulus of minus 1, that is nothing but here 1. So 1 into 1 by 2, it is nothing but 1 by 2 square units. Therefore, area of quadrilateral ABCD is nothing but sum of these two areas. That is nothing but 2 plus 1 by 2 equal to 5 by 2 square units. Let us observe one more example. Find the area of quadrilateral formed by 1, 3, 3, 1, 5, minus 1 and 2, minus 3 in an order. Same like earlier problem, consider A equal to 1, 3, B equal to 3, 1, C equal to 5, minus 1 and D equal to 2, minus 3. Let us observe area of triangle ABC. That equal to half of 1 of, here it is 1 minus of minus 1, therefore 1 plus 1 plus 3 of minus 1 minus 3 plus 5 of 3 minus 1. It is nothing but half of modulus of 1 of 2 plus 3 of minus 4 plus 5 of plus 2. It is nothing but 2 minus 12 plus 10. 2 plus 10 is 12. 12 minus 12 is nothing but 0. So you got the area of triangle is 0. If the area of the triangle ABC is 0, then the 3 points are collinear. Already we have discussed this type of problem. So if 3 points are on the same line, quadrilateral ABCD cannot be formed. So it is, the diagram is like this. So it is not a quadrilateral. So no need to check the other triangle area. Let us observe some important problems. Find the vertices of triangle ABC whose midpoints of sides are 1, minus 1, 2, 3 and minus 2, 1 respectively. Also find the area of triangle ABC. Here they have given midpoints of the triangle but not vertices. So we need to identify the vertices first. Then you need to find the area of the triangle. So let us consider A is equal to x1, y1, B equal to x2, y2 and C equal to x3, y3 and D equal to midpoint of BC that equal to 1, minus 1, E equal to midpoint of AC that equal to 2, 3 and F is equal to midpoint of AB that is equal to minus 2, 1. Now D is midpoint of BC, therefore by midpoint formula x2 plus x3 by 2, y2 plus y3 by 2 equal to 1, minus 1. If you compare both sides, x2 plus x3 by 2 equal to 1. If you simplify, x2 plus x3 equal to 2 into 1 that is equal to 2. Similarly, y2 plus y3 equal to 2 into minus 1 that is equal to minus 2. That is nothing but whenever the sum of these two coordinates is double the coordinate, corresponding coordinate of midpoint. Similarly, x1 plus x3. So if you observe here, x1 and x3 are the vertices of AC. So x1 plus x3 equal to double the 2. That means x1 plus x3 equal to 4. y1 plus y3 equal to double of 3, that equal to 6. Similarly, x1 plus x2 equal to double of minus 2, minus 4. y1 plus y2 equal to double of 1, that is equal to 2. Now consider these three equations are equation 1, equation 2, equation 3. If you add all these three equations, if you observe here, one x1 is there, here one x1 is there, here one x3 is there, here one x3 is there, here one x2 is there, here one x2 is there. That means each one is repeating twice. So if you add all of them, 2 times of x1 plus x2 plus x3 equal to 2 plus 4 plus minus 4. Plus 4 minus 4 will be cancelled, you are getting 2. Similar fashion, 2 of y1 plus y2 plus y3 equal to minus 2 plus 6 plus 2. Plus 2 minus 2 will be cancelled, we are getting 6. Therefore, x1 plus x2 plus x3 equal to 1 and y1 plus y2 plus y3 equal to 3. If you observe now, consider this fourth equation and subtract the corresponding 1, 2 and 3 equations, you will get individually each coordinate. For example, if you here it is x1 plus x2 plus x3 is there. In the first equation, x2 plus x3 is there. If you subtract the first equation from the fourth equation, x2 cancelled, x3 cancelled and x1 we will get. Similar fashion, y2 cancelled, y3 will cancel, y1 you will get. So observe the simplification now. So equation 4 minus equation 1, we can simplify x1 plus x2 plus x3 minus x2 plus x3, that equal to 1 minus 2. Similarly, y1 plus y2 plus y3, that equal minus y2 plus y3, that is equal to 3 minus of minus 2, that is nothing but 3 plus 2. So x1 value is nothing but 1 minus 2 minus 1, y1 value is nothing but 5. Similarly, we can get x2 value is equal to minus 3, y2 value is equal to minus 3, x3 value is equal to 5 and y3 value is equal to 1. So now we got the vertices. Vertices of triangle ABC are minus 1 comma 5, minus 3 comma 3 and 5 comma 1 respectively. Now area of triangle ABC equal to half of minus 1 of minus 3 minus 1 minus 3 of 1 minus 5 plus 5 of 5 minus of minus 3 plus 3. It is nothing but half of minus 1 of minus 4 minus 3 of minus 4 plus 5 of 8. That is nothing but half of minus 1 into minus 4 plus 4 minus 3 into minus 4 plus 12 plus 5 into 8 plus 40. So 40 plus 12 52 plus 4 56. So half of modulus of 56, that is nothing but 28 square units. Suppose if they have asked find the vertices of the triangle, you need to do this process. Instead, they have asked to find the area of the triangle. Then you can use the concept what you have learned in class 9th by using midpoint theorem. So we know that area of triangle DEF, that means triangle joined by the midpoints, is nothing but 1/4 area of triangle ABC. From this we can say area of triangle ABC is equal to 4 times area of triangle DEF. So if you find the area of triangle DEF and multiply with 4, we can get area of triangle ABC. If you have a doubt, you can check with the area of the triangle, find out the area of triangle DEF, multiply with 4 and verify the answer whether it is equal to 28 square units or not. Points to remember. Area of triangle formed by the points x1, y1, x2, y2 and x3, y3 is half of modulus of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. 3 points are collinear if and only if area of triangle that formed be 0. Area of quadrilateral is sum of the areas of triangles formed by the diagonal. Thank you. If you have any doubts in this concept, you can text me. Please subscribe to the Maths Quest.